Good evening, ma'am. Good evening, ma'am.
Very good evening, one and all.
Good evening.
Advita, Hamza, Rishit, Manas, Rohit. Okay.
Good evening.
Let us wait for one more minute.
Okay, ma'am.
Okay, children, let's start now. So now we'll be taking a new chapter, that is light. Fine. I request all of you, please put on your cameras. Chapter number 15, light.
Now, what's the chapter? Can you repeat? Like your voice is low.
Pardon, please.
Ma'am, your voice is low, ma'am.
My voice is low. Okay.
Yes.
Fine now.
Yes, ma'am. It's okay.
Okay. Oh. Any more students to join if any idea? Okay.
Yes, ma'am. More students need to join.
Yeah, ma'am. Like total, the strength should be 11.
Okay. Okay, fine. So, light, the term we have heard many a times in previous classes also, means we had separate chapters on the at this particular topic. So, how do you means what you think? How light is important to us? What role it plays in our life?
Ma'am, it is used for us to see objects.
It enables us to see objects. Okay. Anyone else?
Ma'am, in this exam, will the half exam be light?
Pardon. Speak loudly, Hamza.
Ma'am, in half of the exam, will there be light?
Okay, you are asking in half yearly exams.
No, ma'am.
No, ma'am. The Sunday test.
I'll let you know by today itself.
Okay, ma'am.
Yes.
Ma'am, you're
What are
a
your
new
opinions?
science teacher.
Light is important to you. Can we please first discuss about the topic? Later on, I'll clear your queries. I'll try to clear all your queries. Okay.
Okay.
Let's focus on the topic first.
Ma'am, are you a new science teacher?
Yes.
Okay, ma'am.
Please tell me that how light is important to us.
Ma'am, it like
Even
enables us to do work.
to do work or to see the things.
Ma'am, like to see the things and like make our work easy.
Okay, great. More answers. The more you will say, the more you will speak now, the more you will share. It will be good and great. Means more correction can be done. Do not
Good evening,
hesitate.
ma'am.
Be open. Be free to speak. Very good evening. Anything else about light? We have learned in class 6th only.
It travels
We
in
know
a
all.
straight line. It travels in a straight line.
Very good. It travels straight line. Good, good.
Follows rectilinear propagation of light.
Pardon, please.
Ma'am, it follows rectilinear propagation of light.
Do 2 points means these points are getting repeated now. Any more new point? It travels in a straight line, that is rectilinear propagation of light. It enables us to see the things. Any more points on that?
Travels at the speed of 3 lakh kilometers
No?
per second.
It is a source of
Speak
energy, ma'am.
loudly, please. Very good. It's a source of energy.
Ma'am, also it travels at the speed of 3 lakh kilometers per second.
Uh,
Ma'am, it helps in
3
photosynthesis.
lakh only. Very good. Good, good.
The main source.
Is it 3 lakh? Its speed is 3 lakh only or more than that?
Ma'am, I think it's more than that.
Well, all your points will get clarified. Okay, let me share my screen now. Hold on. I hope a PDF is visible on your screen, class 7 live.
Yes, ma'am. Yes,
Right?
ma'am.
Okay. So the points that you can currently read are the points about the light. Okay. Light is a form of energy. One of you already mentioned it. Just a sec. It's a form of energy which is responsible for the sense of sight in human eyes. Light can be called as a radiation that is emitted, reflected, or absorbed by different objects. So first point, I hope it's clear. Like we have heat energy, we have, say different forms of energy, please. You people only tell me.
Solar wind energy.
How many
Kinetic
Wind
energy,
energy, good.
wind energy, solar energy.
Hydro energy, huh?
Chemical energy.
Okay, very good.
Kinetic energy.
Keep telling.
Kinetic energy.
Very good. Great. More.
Thermal energy.
Heat energy is only thermal energy.
Solar energy.
Like kinetic, we have potential also. We have gravitational also. Magnetic, electric, and a lot more. Right. So light is also a form of energy, but this energy gives us a sense of sight. So suppose if it is all dark in the universe, where we are getting light from? We are getting light from the sun. Suppose sun is not there no more in the universe. What will happen? I think
Ma'am, there will be no light and the process of photosynthesis will stop.
means I don't think the life would be possible for so long in the absence of sun, right?
Yes.
Because if sun is there, we are able to see the things around us because that light only comes to our earth and falls on different object, bounces back from the object and enters our eyes, and because of that only we are able to see our surrounding of all the things, and that's why we have the knowledge of all the things. Otherwise, no light means darkness, means nothing is there for us. So no life. And of course, a very good point that light helps in the photosynthesis. If photosynthesis process fails to occur, no plantation, no plants, no food, and hence it is all zero, isn't it?
Ma'am, so there is no life without light.
So there is.
Means like we can't live without light.
Yeah. You only think yourself and tell me if any other point comes to your mind, like if life is possible without the light, if sun is absent, we can't see the things.
But
How we
like,
will be able to create
ma'am,
an
but
artificial sun?
recently, like
How we will to
a
work?
few countries have made it some artificial suns, like a kind of. So what's the difference between that?
Yeah, with advanced it is possible. And can you please name a country that has made an artificial sun?
Ma'am,
Ma'am,
China.
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 You can
China.
say artificial light, but we can't say artificial sun. The sun is one and only.
Yeah, ma'am. So like in many of the news channels or like Google website, it shows that it's artificial sun.
Okay, so we'll be
Ma'am, they did it by using so many nuclear testings,
Yes.
like nuclear fusion they added to it.
yeah, because in sun also, that hydrogen atoms keeps on combining, means the process of fusion, or you can say the chemical reaction between the two hydrogen atoms keeps on taking place, and by that reaction only the heat and light is emitted, which is making it possible. So yes, because we have a lot of elements in our nature existing, and a few elements are so heavy, means so heavy elements that they keep on emitting the radiation, and they cannot be found in usual areas. They are kept separated. In higher classes, in class 9 or 10, you will learn that many of the elements are not known in the usual life to us people, but they keep on radiating some particles or radiations which are useful for us in several ways. Okay. Next point about light is it is an electromagnetic wave that can travel through medium as well as through vacuum. And can anyone explain the meaning of this word electromagnetic?
Ma'am, the magnet which uses the electric current.
When a magnet is connected to when a temporary magnet is connected with electricity to copper wires, and when it is generated to electricity, then the magnet gets charged and it becomes a permanent magnet through an
Ma'am,
electromagnet.
usually electromagnetism means like when electricity pass through any conductor of electricity, then that conductor behaves like an electromagnet.
Okay, great. Great attempt by all of you. But you are explaining about electromagnet. This is light has an electromagnetic nature, or it is called electromagnet in nature. Why so? Why light means? Okay, if you are telling me electromagnet, what is it? Then how light is related to that?
Ma'am, does electromagnetic wave mean, like, it's my guess, is it any force kind of?
Uh, I couldn't hear you anymore, Rohini.
Ma'am, your voice is low.
I was not able to hear you. Can you please repeat?
Ma'am, is it any force?
I think I missed it, Rohini, so sorry. Anyways, let me explain it now. So light has electromagnetic nature. It is because when light is produced, it charge. You name any charged particles?
Ma'am, electrons.
Yeah, ma'am, like the charged particles. Kind of.
Electrons and protons. Electrons are negatively charged, protons are positively charged. Okay. Just this is I'm telling you just for your knowledge. When these charged particles come into motion, that is when they start moving, they give rise
They produce electricity.
to electricity. And when a conductor varies, it gives rise to magnetic field. So what happens when we produce light in the artificial manner? It is because of the charged particles. They move, means they are now because they have produced current, so they are called electric in nature, and that current varies across the conductor, so that is magnetic also in nature. That this is why the light has electromagnetic
Yes,
nature. Okay,
ma'am, is
you can note this
nuclear
down.
fusion required to generate light?
This because of nuclear fusion, light is emitted, but this is not the only method to produce light. There are several more other methods.
Ma'am, can you repeat again what is electromagnetic wave? Like,
See, electromagnetic word comes from the two different words. Electro comes from electricity, and magnetic itself, magnet, right? So electricity plus magnetic nature is combines and it forms charged particles. When it comes
Ma'am,
into
your
motion,
voice is breaking.
ma'am,
changes
your voice is
rays, it
breaking.
gives rise to
Yes,
magnetic
ma'am, your
field.
voice is breaking.
Okay. I hope it would be fine now.
Yes, ma'am.
Hmm. Understood the meaning of electromagnetic nature?
Ma'am, can you explain again? Because, like, your voice was breaking when you were explaining.
Okay, one more time. Electromagnetic word and magnet. Electro comes from electricity and magnetic comes from magnet, right? Light is said to have electromagnetic nature because light is produced by the movement of charged particles. Charged particle, that is electrons and protons. When these two type of particles move, that is when they come in motion, it gives rise to current. When the charged particles come in motion, it gives rise to current. And when the current through any conductor changes, or you can say it varies, it gives rise to magnetic field. So the two electric nature and magnetic nature both are responsible for producing or generating the light. This is why light is said to have electromagnetic nature. Is it clear now?
Yes, ma'am.
Next point is light has a dual nature, that is particle as well as wave nature. This is based on the theory of two different scientists. Particle nature was told by Sir Isaac Newton, and the wave theory was given by Sir Christian Huygens. And in detail that why it has a particle nature and why it has a wave nature, you will learn it later on in higher classes. Let me scroll the page. I hope the last point is also visible. It travels from one place to another in a straight line, and this property is known as rectilinear propagation of light. Okay, so this was the introduction of the topic light. As you can see in this example in the picture also. See, if you place a candle and take a straight hollow pipe and look through that pipe, you'll be able to see the flame of candle. If you do the same thing with the bent pipe, if you bend the pipe a bit, not in the same way, but anyway, the way you are able to do it, will you be able to see the flame of candle if you bend it?
No, ma'am.
So pretty clear from this little small activity that light always travel in a straight line. It does not varies its path according to the object we are looking at it from. Okay. Shall we move to the next topic?
Yes, ma'am.
Okay. Please. Okay. Give some examples of luminous objects.
Stars, sun.
Ma'am, candle.
Ma'am,
Wait.
sun, star.
Ma'am, a torch.
Torch. Okay. I
Ma'am,
want
bulb.
everyone to
Ma'am,
give one
bulb.
piece.
Ma'am, a
sun.
bulb.
Sorry, apart from those shown in the picture are also there. Some more examples you can give apart from these.
Ma'am, firefly.
Okay, good.
Ma'am, bulb.
Bulb, right? All done. A lamp can be there.
Yes, ma'am.
Fine. So the
Ma'am,
object
tube lights.
tube lights, yeah, bulb, tube lights, lamp. So the objects that generate their own light or they have their own energy are known as luminous objects. And on other hand, those objects which are capable of reflecting light to our eyes means, suppose if we look at the sun, although we can't look at sun for so long because it has its own bright, very bright light, right? So because the light is directly entering from sun to our eyes, we can see the sun. But how we are able to see planets, how we are able to see the door, our bed, our tree, the birds,
Ma'am,
they
we
do
can
not
also
have
see
their
the
own
moon
light.
because
So
we can also see the moon. Even though moon gives light, we can see it because moon does not emit its own light, and moon takes light from the sun.
Yes.
okay. So when the luminous objects emits the light, they fall upon certain objects like a tree, a bird, the road, the car, etc. Their light gets bounced back, enters our eyes, and hence we can see those illuminated objects. So you can say non-luminous objects are only known as illuminated objects. Clear? This is very simple, no need to explain more. So sun, luminous, fire from any means like wood is there. Torch, candle, lamp, a tube light, firefly, stars, those are all luminous. And anything apart from those which do not have their own light are called illuminated objects. Next topic is regular and irregular reflection. I find this topic so interesting. The word itself clears a bit. Regular reflection means reflection of light in a regular way. Or you can say the light rays are getting reflected in a regular pattern, right? So by the name itself, it's only a bit clear. When light falls on a smooth regular surface like a mirror, the entire parallel incident rays are reflected perfectly parallel. I'll show you this with the help of diagram. Suppose I point a torch on this mirror in this way. See, obviously, light is not consisted of like these line type rays. This is only a representation so that we can study it well. Okay. I pointed the torch at, let's say, 30-degree angle. I hope you remember the laws of reflection we have learned in class 6 also.
Yes, ma'am.
What can anyone tell? What are the laws of reflection?
Ma'am,
Angle of incidence equals angle of reflection.
Okay, very good. Another point.
ma'am, just a minute. Let me recall.
It's okay. There are three main
Ma'am,
rays.
also,
The incident ray,
we have
the
incident ray, reflected ray.
and the normal,
Ma'am, they are
all
on the
lie in the
same plane.
same plane. It
Ma'am,
means
90
like
degrees.
hmm?
90 degrees.
No, the angle is not specified. Only same plane. I'm telling you. Suppose look at your laptop screen. If you are drawing something on the screen, this is a two-dimensional, right? So that any you draw line at any angle, this you have to draw it in the two-dimensional only, the length and width. So like this, it is mentioned wherever light is incident upon on any surface, it will be reflected, and that normal, if we draw, they all will lie in the same plane only. The plane will not be
Ma'am,
changed.
also, the plane will be same.
Yeah.
Okay.
If you let me just draw it once again, if in case anyone is not able to recall. Suppose this is a plane surface. Law, I'm telling you, law of reflection, right? The first law is more important. If this light is incoming light, my ray is not so perfectly straight, please excuse me for this. Now, the point where the light falls on the surface, this is known as the point of incidence. Please focus here only, point of incidence. Now, at this point, this is my surface, and on this surface and this particular point, I have to draw a normal. That is a 90-degree line, which is known as the normal, right? Now, the angle which the incident ray makes with the normal is known as the incident ray. Also, the reflected ray will be reflecting back by making the same angle that incident ray has made, R. So the angle which reflected ray makes with the normal is known as reflected ray. Many a times, student makes mistake that they measure the incident angle with the surface, but please don't do. Okay, be careful that incident and reflected angles are always measured with the respective rays and with the normal. Note this thing, please. Fine.
Yes.
This is the
Yes,
reflected ray,
ma'am.
and the incoming ray is the incident. So this angle, if angle I is 30 degree, R will be 30 degree. If angle I is 45, angle R will also be 45. And suppose in case the light is incident at 0 degree. 0 degree means no zero angle with the normal. Means this light is incident this way. Then of course it will get reflect back, making the same angle. The 0 degree will bounce back
Ma'am,
on
if
its
we get
same path.
problems like they will give us the length of they'll give us the length of angle of incident, and they'll give us the length of the what is it called? They'll give us the normal, and then we have to find the angle of reflection.
Pankaj, can you please speak again and little loud?
I can't hear you.
Can you please speak again and little louder? I couldn't hear you properly.
Ma'am, like will we get problems like they will give us the length of angle of incident and the length of the normal, and they'll tell us to find the length of angle of reflection.
Length here doesn't matter. See, this ray is only a representation of light. Light is a beam, it is not a ray in this form of an arrow. It is not so. Don't get confused. Here only angle matters. Okay? Length of ray doesn't matter. It might happen that you can be provided, suppose the angle of the angle of incidence ray, you have to subtract this given angle. Suppose you are provided a 30-degree angle here. 30
Ma'am,
degree
your
that
voice
ray
is
is
low.
making to the surface. Minus 30. If in case the question is asked to you in the form reflected angle, what you have to do, if you draw a normal and subtract 30 from 90 degrees, because it is made with the normal only, 60. So here 60 is our incident, and of course 60 will be our reflection angle.
Ma'am, you couldn't
Here,
hear, like your voice is very low. I hope it will be fine now. Audible? Am I audible now?
Yes, ma'am.
Yes, ma'am.
Ma'am, we can't hear in.
Seventh class, am I audible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Sharing my screen again. And they have the regular reflection. Regular reflection is, suppose this is a mirror and I point a torch beam light from the torch this way. And let's say I'm not mentioning everything here. Let's say the angle of incidence is made by all the 30 degrees. Okay. Now after drawing, yes,
Ma'am, your voice is echoing.
Yes, ma'am.
okay.
Ma'am, your voice is breaking.
Is it now fine? Is it now okay?
Yes, ma'am. Now it's okay.
And so let's say that all three rays are making angle of incidence 30 degrees. Then after drawing the normal, you will find that all the three rays will be reflected back at making 30-degree angle only.
Ma'am, those three
As
rays are like from three torches or the
pardon,
ma'am, why are there three rays? Like if it's like one torch, it'll be one beam of ray, right?
dear, see, we have to study about light and light. The way we see, look at here the tube light and the bulb in your room right now. Is it in the form of an arrow, a straight line? No, we can't see like that. So light is a beam. Beam. Are you getting it? It is not a particular ray, but we have to study it in some way. So we draw a light. You can draw two, three, four, five, any number of rays. That doesn't matter.
Okay, ma'am.
Hmm. So you will find that angle of reflection also will be made 30 degree. So as mentioned here in the definition, when the light falls on a smooth regular surface like a mirror, it reflected perfectly parallel. And this gives rise to the image formation. So any of the surface, it is not only with a mirror. Yes, mirror perfectly can be called said to have to exhibit regular reflection, but there are several other things. Can you state some examples where regular reflection occurs?
Ma'am, like glass.
Glass, very good.
In
State
clear
more,
water.
very good. Clear water, and we can say still water. If the water
Yeah.
has waves, then the no image it's possible. You know, clear
Yeah,
and
ma'am.
water. If and in case of muddy water also, it will not possible.
Ma'am,
Ma'am,
so ma'am, will light pass through water or will it like reflect?
There are two phenomena in this case. Little of light is absorbed also, means passed through it, refracted also. Some of light reflects back also.
Okay, ma'am.
Another example is polished metal. Highly polished metal, like if when you buy a new utensil, a new plate, you can clearly see your image in that. Many of the utensils occurs this, and we can see our image.
Yes, ma'am.
So get more examples of regular reflection, okay? Because time is almost over. We'll continue with the next topic in the next class, diffuse reflection. And please note one thing, that regular reflection is also called a specular reflection because of uh, perfectly parallel reflected rays, it give rise to image. If you will read by your own, you'll come to know that in diffuse reflection or irregular reflection, it does not happen because the reflected rays are not reflected perfectly parallel. They are moving in the random direction due to the irregular surface. Anyways, you just focus up till regular reflection. I'll be sharing the notes till here only. Come up with the more examples of luminous, non-luminous object and regular reflection. Fine.
Okay, ma'am. Okay, ma'am.
Okay.
Okay, ma'am.
Let's
Thank you,
summarize
ma'am.
the topic a little bit. Wait. 2 minutes are still left. Let's summarize the topic. Why the light is said to exhibit electromagnetic nature? Anyone? Full tell.
Ma'am, can you repeat the
Why light
question?
is said why light is said to exhibit electromagnetic nature?
Can I say?
Hmm. Yes, please.
Ma'am, like when the charges come in motion, they produce electricity. Like to
Ma'am,
produce light, two
ma'am,
things are required. One is
ma'am, can I say?
Ma'am, can you repeat the question?
Why light is said to exhibit electromagnetic nature?
Ma'am, can I answer?
Yeah, please.
Ma'am, because of the charged particles such as electrons and protons, which create the electromagnetic fields when they move, and these fields transport the type of energy, and that is called light.
Very good. I'll tell more about light. So, okay, let's meet in the next class now. Okay, bye bye.
Bye, ma'am.
Bye. Thank you.
Bye,
Bye,
ma'am.
ma'am.
Thank you, ma'am.
Bye bye.